Okay, so to do these problems, we have to look at our strategies. So what are some strategies that I gave you guys in the video? Look at the Pythagorean identities. So if we look at number 2, you can see that our problems there have squareds in them. So that means that to do problem number 2, we should be looking at our Pythagorean identities. Okay? Don't say what you're doing out loud, but I want you to try number 2, looking at your Pythagorean identities. So we're working on number 2 right now. Number 2. Sheet. Alright, so I shouldn't hear any talking. You're just trying number 2, and you're using the Pythagorean identities to do it because the problem has squareds in it. Okay, anyone want to share what we might be able to do? Yeah, so if you see here, your Pythagorean identity says that secant squared is the same thing as 1 plus tan squared. So what we can do is we can take this right here and we can replace it with 1 plus tan squared x. Okay, so I'm going to go ahead and write that out. That means that I have tan squared x minus, and since I'm taking one term and replacing it with 2 terms, I need to put parentheses there to make sure that I subtract both of those numbers, okay, or both of those terms. So I've got 1 plus tan squared x. So I said when we go through and do these problems that we typically bounce back and forth between making a substitution and doing math moves that are things that we've learned how to do before. So we just made a substitution. The math move that we should make now is doing what we know we should do to get rid of parentheses. What do you do to get rid of those parentheses? Distribute, right? So let's go ahead and distribute that negative. So we have tan squared x in the front, and then we're going to have minus 1 minus tan squared x. And then what happens? If you combine like terms, what happens to the tan squareds? They cancel. You have a positive version and a negative version, so they're gone. And then that means that your simplified answer would be negative 1. Okay, so that one's done. All right. Let's go ahead and try number 1. So number 1 doesn't have any squareds in it. So what's another strategy on our notes that we could maybe try? We could use reciprocals, right? So you have a cos right here. If you look at the reciprocal identities, what could you replace secant x with? 1 over cos. So this right here, I'm going to replace with 1 over cos. So I just went ahead and I did a substitution. So I have 1 over cos times cos. And then what happens when we use our math after that? They cancel out. If you multiply by cos and divide by cos, that divides to give you 1. And so what's your final answer? 1. Okay. What's one of the other strategies that was listed on your sheet? Nope, not the identities, but on your notes last night I gave you some strategies. So don't look at your identity sheet. We're not looking at our resource page. We're looking at the notes that you wrote down. And I gave you some strategies. So I said get a common denominator. What's another strategy? Get everything in terms of sine and cos. So we're going to try that for number 3. So anytime you're working with a problem that has a mixture of trig expressions, it has like a bunch of different of the trig ratios, not ratios, trig functions. It has multiple trig functions. Anytime that happens, usually getting it in terms of sine and cos works because there's a lot of different things that you can turn into sine and cos. So on your sheet, what could we turn a secant into? 1 over cos. Okay, so I'm going to call that 1 over cos alpha. What can we turn a tangent into? What can we turn a tangent into? We can turn it into sine over cos. So tangent can become two things. It can become 1 over cotangent, or it could be sine over cos. So if we're using the strategy to turn everything into sine and cos, then we should use the second one. Okay, so we're going to do sine over cos for this one. And then the last one, we're going to leave cos just the way it is. So what we did is we just took that problem and we turned everything into sines and cosines. So what happens? Yeah, the multiply by cos and the divide by cos cancel. So there's a divide by cos, there's a multiply by cos. We have a sine over cos left over, and what's sine over cos? We just said it, right? It's tan. So we're just going to say tan alpha would be the most simple, and that's our answer. Okay, I want you guys to try number 4. You're going to do it quietly. And since there are multiple trig functions in this one, the strategy that we're going to use is to turn it all into sine and cos. Okay, so take a moment. You're going to do every piece in terms of sine and cosine. So what can we do with cotangent? Cos over sine. And what can we do with cosecant? 1 over sine. Okay, don't say anything. See if you can figure it out. If it helps, you can put this over a 1. All right, anyone see what we could do? Yeah, so sine squared on top cancels with sine squared on bottom. And so cos, yeah, and the 1s don't need to be there, so cos is our answer. Yeah. So you always have to do sine of something, and so it's just a different variable to represent the angle that you're doing sine of. Yeah. Okay. So if we look at a problem like number 6, go ahead and look at your sheet. In problem number 6, we can see that the tan squared is alone, and we can see that the 1 is over with the secant squared. So sometimes it's beneficial when we're looking at the Pythagorean identities to look at an alternate form of it. And so you can see they kind of did it already with the sine squared, cos squared one, where they gave you 2 alternate forms of the exact same thing. So they said sine squared plus cos squared equals 1, Or if you want to get sine squared alone, you can just minus the cos squared to the other side. And that gives you another identity that would be sine squared equals 1 minus cos squared. Or if you wanted to get cos squared alone, you could take the sine squared and minus that to the other side. And then you could say cos squared is 1 minus sine squared. So there's alternate forms of these two trig identities as well. So the alternate form for this one would be, I can say tan squared should be all by itself. And the way that I would get it all by itself is if I take this 1 and I minus it over to the other side. So tan squared is the same thing as secant squared minus 1. And then I can go ahead and use this as a substitution. Okay. Now, when we make our substitutions, we want the problem to be more simple, not more complicated. Okay. So if I look at problem number 6, I do not want to take the top and turn it into secant squared minus 1 because that makes it more complicated, not more simple, okay? But it would be beneficial for me to use the bottom and try to manipulate the bottom because I could make it more simple. Do you see how similar the bottom is to what we just talked about? What's wrong with it? It's in the wrong order. Do you guys see that? Okay, so let's go ahead and switch the order of the bottom. So I'm going to say tan squared over, and I'm going to do negative secant squared plus 1. So you can switch the order as long as you keep the sign. The secant squared was negative, so I'm keeping it negative. How could we make that look more like what's on our sheet? Take out the negative, yeah. So we're going to leave tan squared on top, and on the bottom we're going to take out a negative, and what does that give us? Secant squared minus 1. Now, what we just did is not unique to this unit. We've done that before, where we switch the order of things and take out a negative. That's a strategy that we've done in the past, okay? Now, is there a substitution we could make that would be beneficial? What could we do? You can take the secant squared minus 1 over here and replace it with what? Tan squared. So this right here can become tan squared. Okay. So on the top, I still have the tan squared. On the bottom, I still have the negative. And now I'm going to go ahead and take secant squared minus 1 and replace it with tan squared. So I'm just substituting it out. And then what do you guys see? Cancel. And what do we get? Negative 1. Okay. So mathematically speaking, these are no different than math that you've done already. Everything that I'm going to ask you to do today is math that you've already done, but it's kind of like if I just taught you Spanish and then I started to ask you to think in Spanish. It'd be like, this is uncomfortable, I don't know this language. That's kind of how this assignment feels today, is you're doing the same stuff you've done before, but it looks so much different, it's going to feel uncomfortable, okay? And the best way to make these easier is just to do more and more of them, okay? So when you get stuck on a problem, you're going to look at those strategies and you're going to work your way through the strategies, okay? So it might be, I see a squared in the problem, so maybe I need to look at the Pythagorean identities. Maybe it's that the problem has a bunch of different trig functions in it, so I'm going to turn everything into sine and cosine. Maybe it looks like it could be factored, so I'm going to try to do difference of squares with it, or I'm going to try to do GCF with it. Maybe it's that I see that there's a relationship between two of the things. Maybe there's a cotangent and a tangent in the same problem, so I'm going to look at that. So work your way through the strategies, and then call me over if you need me to help give you a hint. Okay? If you look on the worksheet, at the very bottom, here's where all the final answers should be. I have no problem with you looking ahead to see what the final answer is before you do the problem, okay? But you should only be going up to the board to see my work. If you have tried it, your neighbor has tried it. Awkward. You've talked about it with your neighbor, you've asked me a question, then you can go look at the board, okay? So the final answers are here. I don't want you to look at my work until it's like last resort. I'm so frustrated and I hate my life, okay? All right, go ahead and get started. Alternate form.
Okay, I wasn't sure if I didn't know when you had to write it.
Well, you can use the alternate forms just like you can use the original. So if you don't think of it that way, it's good to have it written down so you can use it.
Thank you.